Right, our last lesson here for Unit 2. We're going to just wrap up our discussion that we started yesterday about linear inequalities. So 2.11 day 2, we're just going to make sure you're really solid with those inequalities with two variables. We're going to make sure you understand really well how to determine if things are solutions, but also get into some of those real world situations, some word problems, and making sure you understand how to solve those by graphing. So that's our plan for today. So our warm up today is just a little bit of a recap from yesterday, making sure you understand how to determine if a point is a solution. So is the point 5, -2 a solution to the inequality 2x minus 3y is greater than 16? And then making sure that you could really explain that reasoning. You could jot down some thoughts on how you might explain it here. If you haven't tried this yet, go ahead and pause your video and do that now. So how I would check to see if this was a solution, since I don't see a graph on here, I can't graph it and shade it, I would just go ahead and plug 5 in for x, and I would plug in -2 for y into this inequality and see if it works. So I have 2 times 5 minus 3 times -2 is greater than 16. Let's see, 2 times 5 would give me 10. -3 times -2 gives me +6, greater than 16. 10 plus 6 would be 16, is greater than 16. Ooh, that's tricky. But be careful about what this inequality actually is. It says 16 is greater than 16. Is that true? No, this was not a solution, right? Because when I plug in those points, I get 16 is greater than 16, and that's not true, okay? Because there's no underline, there's no or equal to. Now, to explain your reasoning, you could say like the number 16 isn't greater than 16, it's equal to, and there's no underline here, right? The other way you could explain it would be to really visualize what that graph would be, right? If this was a greater than symbol, it would just be a dotted line. This 0.5 -2 would land on that line, but since the line is dotted, it's not a solution. The points on the line are not solutions to that inequality. Would be another way that you could explain your reasoning on that one if you're thinking in terms of a graph. So hopefully that helped you just kind of get your brain back moving in the direction that we were moving yesterday. So let's just make sure that you remember how to actually graph those inequalities and determine if you have solutions or not. So go ahead and pause the video and just try this one out. So the first step to graphing is to put it into slope-intercept form. Now this one looks a little bit different, right? And maybe you caught it, but in order to get into slope-intercept form, I have to get y by itself. So I have to divide both sides by 2. Not a lot to divide here. I am dividing, but not by a negative, so my symbol does not have to flip. So I get y is greater than 4 divided by 2, which is 2. No x, no slope, no y-intercept. This is one of those different kinds of lines, right? They still come into play. What kind of a line are we talking about here? No slope and y-intercept. Instead, we say, some of you are probably thinking of this little word that helps you remember. This is a horizontal line, right? A horizontal line, flat like the horizon, that has to go through y equals 2, right, which would be this one right here. But before you get ready to just draw that line, don't forget to check your inequality here, right? This is a greater than, not a greater than or equal to. So since it's just greater than, this would mean that I have a dotted line. So I need a dotted line going through that's horizontal, that goes through y equals 2. So it's a little bit tough to see that my line is dotted, but hopefully you can see it fairly well. Do your best to make yours dotted as well. So I need a dotted horizontal line here. Don't forget, horizontal and vertical still exist. All right, now I need some shading. Now our inequality is y is greater than 2. Now hopefully it's pretty obvious which side you want to shade on. But if you're just in that mode of checking the point, let's definitely do that just to make sure, right? Again, the easiest point to check here is the point 0, 0. Even though I have an idea of which side I'm going to shade on already, I'm just going to go ahead and use that easy point to double check. So if I plug in the point 0, 0, I would have 0, I'd have 2 times 0 is greater than 4. Right? If I go back to the original, you could plug in 0 is greater than 2, but this way you go back to the original just in case I goofed anything up, right? 2 times 0 is 0, so I have 0 greater than 4. Is 0 greater than 4? Nope. So double checked, my idea was correct, so I am not going to shade on the side that has that 0, 0 on it because I checked that point and it's not a solution, so I can't shade that side. I need to shade the other side. So I'm going to shade above my line here on this one. Now, some of you probably could figure that one out without having to plug in the point because it was that horizontal line, and that's okay in this case. But just to double check and make sure you're positive is always a good idea. Okay, so I've got my graphing, I got my line, I checked for dotted and solid, I checked the shading. So now I'm going to go in and check out these points. So the first one is the point 1, negative 1. 1, negative 1 is right here. Definitely not a solution, right? Not a solution. It's not even close to the shaded area. Okay, how about the point 3, 0? 1, 2, 3 and up nothing? Nope, not a solution. All right, how about our last one here? This one here, the point 4, 2. 4 to the right and up 2. Ooh, how about this one? Still no, because that line is a dotted line. All right, so that one was trickier because it is on the line, but the line is a dotted line, so it's not a solution. So just be careful there. All of them that I gave you were not a solution. That's okay. I didn't want to get you into any like, oh, there always has to be one solution. So, one of these has to be wrong. It's okay. Use your graph. Make sure you understand it, right? Where would be a point that is a solution? Boy, if I picked any one of these points, let me get a different color here. Maybe this point, right? Negative 1, 2, 3, 1, 2, 3, 4, negative 3, 4. That would be a solution because it's up in that shaded area. So that is a solution if you wanted to create another one. Negative 3, 4 is a solution. But don't get fooled that just because they give you a point, you got to have a solution in there. Just check your graph. All right. So that was a good review of horizontal and vertical lines. Remember, those still come into play even for inequalities. But when you're dealing with linear inequalities, you have this whole coordinate plane. It still looks a little bit different than just the number line. So be careful about that. It was also a really good review of all your dotted and solid and shading things from yesterday, as well as using the graph to determine if you have a solution or not. So that's really going to help us when we get into this word problem. So here we have Francesca, who can spend at most $6.75 on healthy snacks for a party. Veggie chips cost $1 per package, and grapes cost 75 cents per bunch. Find 2 combinations of veggie chips and grapes that Francesca can buy. All right. Now, the first thing we need to do is decide which one is going to go on the x-axis and which one is going to go on the y-axis, and just define my variables here, right? Whenever I have a word problem, the biggest thing to do is define my variables. So, you could do anything you want. Since veggie chips come up first, maybe we'll call veggie chips x. So x equals the number of veggie chips. And since I noticed that my graph doesn't have any labels on it either, I'm going to go ahead and put veggie chips on my x-axis as I go. Right now I do notice that it has a number 10. So just to help me out, this is 1, 2, 3, 4, 5, and so on, right? Just to make sure. Okay, so that must mean that grapes will be y. So y equals the number of grapes. Now you could switch it around if you wanted to, but this way we'll all just kind of be on the same page. So over here will be grapes, I should say number of grapes, and again here 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a number in front of my veggie chips. Okay. So let's see if I can write an equation here. Let's see. She can spend at most $6.75, and veggie chips are $1 per package. Grapes cost 75 cents per bunch. So let's see. Veggie chips are $1 per package. So $1 times the number of packages, right? Plus, grapes are 75 cents, so 0.75 times the number of bunches of grapes, which is y. And this needs to be at most $6.75, at most. So when I add up everything I'm spending, the 1x plus the 0.75y, when I add up all of that, it can be at most $6.75. Could it be less than $6.75? Yeah, I could spend less than $6.75, but it can't be any greater than that. So less than or equal to would be the symbol I want for at most, right? It could equal $6.75. It could be less than $6.75, but it can't be greater than that. So that's the symbol that I want. And that's kind of the process I go through when I'm trying to determine my inequality. And honestly, guys, that's probably going to be the hardest part for you because you're going to be such pros at writing equations by now. But just really slowing down, double checking, right? Do you have the right symbol? And the way that I do that is, could it be less than? Could it be greater than? What if it's equal, right? And just kind of work your way through it. Okay, so I have my my equation here. All right, so let's see what I've got. I want to get this into slope-intercept form in order to be able to graph my line and shade it to find some combinations, right? So the first thing I'm going to do is I am going to move that x to the other side, right? 1x, x, same thing. So I have 0.75y is less than or equal to, let's see, negative x plus 6.75. Ooh, I cut it a little close there. Maybe I'll move this guy over. Technology. Okay, good enough. All right. Oh boy. Now, maybe, it's 0.75. I've got all my fractions going on. Maybe I want to change this into my decimals going on. Maybe I want to change it into a fraction just so that I can deal with it a little bit easier, because I'm talking about slope and stuff, and that's dealt with in fractions. So I'm just going to change all my decimals into fractions really quick. Now, we did a lesson on this early on, so hopefully you're okay. So this 0.75, whoops, there we go. 0.75, that's really 3/4, right? So I'll have 3/4 y is less than or equal to negative x plus, here I have 6 3/4. 6 3/4, right? 6 3/4, though, I could write that as a mixed number. Let's see. 6 times 4 is 24, plus 3 would be 27. So this is really 27/4. Okay. So I just took my two decimals and I changed them into fractions because I know I'm going to be dealing with slope and need a rise over run and things like that. All right, so now I need to get rid of my 3/4 over here by the y. Do you remember how to get rid of a fraction? I multiply by the reciprocal. And I need to multiply every single one of these things by the reciprocal. So 4/3 times 3/4 cancel out. I have just plain old y. I am not dividing or multiplying by a negative, so my symbol stays the same. Negative x times 4/3 would be negative 4/3 x. There's a really easy slope to use right now that I converted into a fraction instead of having a decimal going on in there. Ooh, and it looks like I can do some simplifying over here, right? You could get huge numbers, do 27 times 4 over 4 times 3 is 12, but oof, let's do some canceling out, right? The 4's cancel out here. 27 over 3, oh, the 3 cancels out. This becomes a 9. It's just plain old plus 9. Check that out. All right. So hopefully, all of these equations are not going to be that hard to convert into slope-intercept form. I picked one that was really tough to convert into slope-intercept form to show you guys you can do anything. That wasn't that bad. You got this. If you can do this, you can do any equation at all converting into slope-intercept form. You got it. Okay. Now, I have it in slope-intercept form. My slope here is -4/3. My y-intercept is +9. So here I am at +9. Counting out my slope, down 4, 1, 2, 3, 4, run 3, 1, 2, 3. Do it again, 1, 2, 3, 4, 1, 2, 3. All right. And now I need to check dotted or solid line on this one. What do we have? I see that we have a solid line because I have an or equal to, right? So solid line, and I'm not going to have arrows on the ends of this one, right? Because I can't have negative number of grapes or negative number of veggie chips, right? I suppose you could argue the fact that I probably wouldn't have a solid line at all because I can't have partial bags of chips or partial bags of grapes, but let's go with solid to get the inequality idea down on this one, and we'll just kind of not worry too much about that other one. All right, now the next thing I need to do is figure out my shading. Which side am I going to shade on? So again, I could check out the point 0, 0, right? You could probably use logic on this one to check your point. If I need to spend at most 675, you can probably guess which side of the line I'm going to shade on. But I'm going to do it justice, check my work just in case, right? So here I would have 1 times 0 plus 0.75 times 0 is less than or equal to 675. 0 plus 0, so is 0 less than or equal to 675? And the answer is yes. So I'm going to shade the side that has 0, 0 on it, which is pretty logical. I'm sure that's what you were thinking already. Maybe since this is a real world situation, you didn't actually have to check the point. You could use your logic to figure it out, and that would be fine as well. All right, but this is the part I'm going to shade on. So anything in this shaded area or on the line are solutions since it's a solid line. Now notice our problem asked us to find 2 combinations, right? So I could pick any 2 combinations I want. Let's say this guy right here. So that would be 4 bunches of grapes and 1 bag of veggie chips. Bag of veggie chips is 1 good combination. Boom. Okay. Excuse me. What's another good combination? Another good combination might be, I don't know, let's go here. 3 bags of veggie chips and 1 bunch of grapes. 1 bunch of grapes and 3 bags of veggie chips. Now, notice I did not write my answers as points on this one. I labeled each of those numbers, right? We're so used to pulling out, okay, here's the coordinates of my answer, but this was a real world situation. Those numbers have meaning. If I just said one good solution was 4, 1, 4 whats and 1 what's, right? And if you get those backwards, 4 veggie chips and 1 grapes, maybe it's not a solution anymore. So be careful, right? So whenever you have a real world situation, label those answers. Don't write your solution as a point, write it with the labels. But other than that, hopefully you can really tackle even the real world situation given that linear inequality. Okay, so our wrap up for today. Just make sure that you are really defining your variables, watching the label of your graphs and all of that, all right? And then be careful about the wording to determine the correct symbol you need. Less than, greater than, which one is it, right? And then, as always, the solutions are the points in the shaded area or on a solid line. All right, wrap up this unit with some good practice and please ask those questions if you have them.